please just keep in mind, all the problems we're looking at this point in time are ignoring drag, are ignoring air resistance. So please don't ask me, well you can, I'll just say we're ignoring it. I know that's hard because real life we really can't get rid of drag. There's nothing we can do about that. But we are going to ignore it for now because it is very mathematically challenging to take into consideration. So we have a ball. It's being thrown downwards at 12 meters per second off a 30-meter tall building. How long does it take to hit the ground? So here's our ball, headed downwards, 12 meters per second. I'm assuming the ball is approximately 30 meters off the ground. So even if I was throwing it, that 1 meter is not going to have a huge effect. So same approach. Since only gravity is acting on it, the acceleration is constant. So write down the variables. Where would you like to put the origin? Where the ball is? Let's take a vote. Where it is to begin with. Where it ends. Sorry guys. So we're putting our origin right here. So that means our initial position is 0. By the way, it doesn't matter. Okay, for those of you who wanted the other, that's a perfectly valid way. Doesn't matter where you put it. What matters, x final, is what? Negative 30, because we end up below it. That's what matters, is you get the correct sign on it. Okay? Initial velocity, negative 12 meters per second. Final velocity? We don't know. Exactly right. It's the impact speed. We don't know how fast the ball is going when it impacts the ground. Acceleration, negative 9.8 meters per second squared. Time is what we're looking for. Okay. Yes?
I have a question. It says it's being thrown down. So the only time you would account for acceleration of something being thrown down would be as if they told you. That would be like
Well, so we're assuming this is how fast it's going when it leaves the person's hand.
okay.
So we're assuming once it leaves the person's hand, it's now traveling at 12 meters per second. So we're not worried about the acceleration that the person's hand contributed to it.
Okay.
We already know that the person's hand got it going at 12 meters per second.
Okay.
Okay? It's a good question. All right. So our equation that has these known values in time is this. Set our initial position is 0. We know the initial velocity, the final position, the acceleration. Half of 9.8 is 4.9. We have time in a couple terms. We can write this as negative 4.9 t squared minus 12t. We need to bring that over, so plus 30 is equal to 0. How do we solve this?
Factor out.
You cannot factor out the t.
Oh yeah, it's not quadratic.
Quadratic equation. A, B, C. Negative b is equal to, what is it? Negative b plus or minus the square root of b squared minus 4ac over 2a. Or yes, I use the solver on my calculator too, if it turns on. Come on, please. Thank you. Yes?
Do you use the other equation that solves for final velocity and negative time?
Certainly. That is perfectly valid. So my calculator is giving me two options, 1.5 seconds and negative 4 seconds. Yes, we're not going to be time travelers. We're not going to be going back in time for anything. So no negative times. But yes, the question is asked, can we find the final velocity first and then find time? Sure. You can use this equation. So initial position is 0. So our final velocity will be plus or minus the square root of negative 12 meters per second squared plus 2 ax. You do need to be careful. Remember, whenever you use this equation, be careful to remember to put the correct sign on it. So I get 27 meters per second. But it should be negative because it's headed down. And then you can use our equation with velocity and time. Which better be 1.5 seconds. So yes, there's certainly more than one way to get to the same answer. It's good to recognize that. If you remember the quadratic equation, or if your calculator solves quadratic equations just fine, that first way works great. If you don't know how to do the quadratic equation, you don't remember it, and you don't know how your calculator does it, take a couple steps. No problem. Okay. Both ways get us to the same answer.